they would try to apply the power of a power rule, and when they did that, the numbers got a lot bigger, a lot more complicated, and they found it hard to simplify. Now, what should you do before you apply the power of a power rule? You look inside your bracket, and you have to figure out, can we make this easier? Do you see things that you can combine and simplify? Well, I know 14 divided by negative 7 can be done, and x to the power of 5 divided by x, that's also doable too. So let's write that down. 14 divided by negative 7, x to the power of 5 divided by x to the power of 1. What operation am I going to do to my powers, my exponents? Delmar, when you're dividing, what should I do? Subtract my exponent. So 5 minus 1. Do I do anything with my y? No, because y doesn't have any, there's no other y that I can combine it with. So I have my y cubed. Now don't forget, this is all the simplification inside the bracket. I still have to put big square brackets, because to all of this, I need to apply the power of 5 to this. So let's go ahead and simplify. 14 divided by negative 7 is going to give me negative 2. X to the power of 5 minus 1 is x to the power of 4, and y cubed remains y cubed. So now that I've simplified, I can apply my power of 5. So that power of 5 is going to be applied to the negative 2, to the x to the power of 4, and to the y to the power of 3. So I'm applying the power of 5, the power of 5, and the power of 5. Okay, so negative 2 to the power of 5, is that going to give me a negative number or a positive number? What do you think? Negative. Good. It's actually negative 32. X to the power of 4 times 5 is going to give me x to the power of 20. And y to the power of 3 times 5 is going to give me y to the power of 15. So very simple when you're following the proper procedure. Okay, we're doing well for time. So those are the majority of the power that we've already gone through: the exponent rule for multiplication, division, power of a power, power of a quotient. That's 4 major rules. Now we're going to talk about negative exponents, which is the equivalent of my bad grammar in mathematics that we need to rectify. So first I'm going to give you the mathematical definition of the negative exponents formula, and we're going to translate this into a rule that you'll be able to remember and apply. So just copy this down for now. So the whole point of this formula is to try to get rid of the negative exponent. So when I start with a, I end up with 1 over a. When I start with 1 over a, I end up with a over 1. So what am I doing to get my final answer? What is the word I'm looking for? The reciprocal, but sometimes reciprocal people forget what that means. So the rule that I want to tell you, you always take your base and you're going to flip the base. So flip the base. That's essentially taking the reciprocal. And the second step is to change your exponent to a positive value change your exponent to a positive value, and after that you can apply any exponent rules. So whenever you encounter a negative exponent, you should never leave that in your final answer. You have to apply these rules to get rid of the negative exponent. Flip the base, change the exponent to a positive value, and apply your exponent rules. Okay, so let's start off with very simple examples, and then we're going to quickly get more complicated. So I'm going to translate the first formula into a numerical example. So if I give you 7 to the power of negative 3, and I ask you to solve that, how do you flip the base? What are all whole numbers sitting on top of? What are all whole numbers sitting on top of? An imaginary? Yep, 1. Good. So if 7 is sitting on top of an imaginary 1, when you flip the base, this is going to become 1 over 7 to the power of positive 3. 1 over 7 to the power of positive 3. And because 1 to the power of anything is still 1, this is going to become 1 over 7 to the power of positive 3, which you can then punch into your calculator to get the value of, which is equivalent to the formula that we have here. Now, if we start off with the reciprocal of 7, so if we start off with 1 over 7 to the power of negative 3, to flip that will become 7 over 1 to the power of positive 3, which is simply just 7 to the power of positive 3. Okay, so flipping the base is very, very straightforward. Do one more easy example, but this time we're going to have a number in the numerator and a number in the denominator. Okay, 2 over 5 to the power of negative 2. Okay, that's not my list. So where is Abigail? Where's Abigail? Okay, so Abigail, what is my new base when I flip it? When I flip it, flip the numbers. 2 over 5 becomes 5 over 2. And what happens to my exponent? It changes from negative 2 to a positive 2. Good. Now, this is a little bit different because now I have to take that power. I can't just leave it like this. I have to apply the power of a power rule, power of a quotient rule. So apply that power to both the numerator and the denominator. So that gives me 5 squared over 2 squared. And 2 squared is 4. Good.